Hello students, so today we are going to learn about binary subtraction using ones and twos complement. This is the term complement. So complement means an operation by which we will perform subtraction by adding the numbers, not by subtracting the numbers, but by adding the numbers we are going to perform subtraction. Okay, so if we subtract 3 from 5, okay, so we will get 2, isn't it? This is a form of subtraction. Now if we divide this or we split this form, we will get the data as 5 and another number as -3. Okay, -3 is also a number. It is a negative number. This is a positive number. Now we have two numbers. Okay, now we can add these two numbers. This is also possible, isn't it? In this case, what we are doing is we are adding two numbers to get the result of subtraction. The same concept we are going to apply in binary number system. The use of complement is that we are going to represent this -3, since there is no minus in case of like binary number system. So what we will do is we will represent this -3 by using the complement form. So you will understand once we start. There are two types of complement, ones and ones and twos complement. First we will learn how to find the ones complement and the twos complement of a given binary number. Now let's take a binary number 11010. Suppose this is a binary number. Okay. The ones complement of this binary number, ones complement of 11010 is just the opposite of every binary digit. Means every bit. So this one will become 0, second one will become 0, third is 0, it will become 1, just the opposite. Fourth is 1, it will become 0, and fifth is 0, it will become 1. It is so simple, isn't it? The ones complement is just the opposite of every bit for binary number. Now twos complement, how to find the twos complement? Twos complement of the same number. Twos complement of the same number will be the ones complement. Ones complement is this one plus 1. Now we are going to perform binary addition, okay, not normal addition. 1 plus 1 will become 2, isn't it? But that is normal. In case of binary, if we add 1 and 1, it will become 0, but it will give a carry of 1. If there are 3 ones, we will get 1, but it will give a carry 1 also. In this case, we have two ones. 1 plus 1 is 0. And I have taught you this in offline class, isn't it? 1 plus 1 is 0, carry 1. So this 1 and this 0 will become 1. And this is 1, 0, 0. So this is the twos complement of 11010. So simple. Now in another case, 10100. Okay, this one. Let's try this one. Ones complement will be 01011. So simple. Twos complement will be this plus 1. Okay, let's find out directly. Okay, 1 plus 1 is 0. 1 plus 1 is 0, carry 1, 1, 1, 0. Right? So this is the twos complement. Let's try another one. 1 0 0 0. Ones complement will become 0 1 1 1 and twos complement will be plus 1. That is 1 plus 1 is 0, carry 1, 1 plus 1 is 0, carry 1, 1 plus 1 is 0, carry 1, 1 plus 1 is 1 plus 0 is 1. Now the twos complement of 1000 is same, 1000. Now there is another method of finding the twos complement, and that is the direct method, shortcut method, the other way. What we will do is, in this case, for finding the twos complement, we will search from the right side. Okay? The first one, until we get the first one, we will copy the same digit as it is. Okay. Now for example, let me take the first number only, 11010. Check from the right side, we will copy the digit same. Okay, until we get the, not until, but till we get the first one. till we get the first one, means till here, we will copy the same digits. Okay, so 0 will become 0. This is the first one will be copied as it is. Now after that we are going to reverse the digit, means 0 will become 1, 1 will become 0, 1 will become 0. So this is the 2's complement and this is a direct method. Check the answer. See, both are same, isn't it? This is a direct one. Now let me try for this one. Okay, we will check from right side. 0 will become 0, 0. Now we got the first one. Till first one we will copy the same bit. Okay, now after that we will reverse. Now 0 will become 1 and 1 will become 0. Now check the answer. This one. This is shortcut method. After that we have this one. 0, 0, 0 means from right side we are going to copy everything, but the first one, also the first one we will copy the same. Okay, after that we are going to reverse, but there is no number, there is no digit after 1, so the answer is this one and the answer is correct, right? Now let me take another example. Suppose if this is the case, then we are getting the first one in the first place only. So 1 will become 1. Till first one we are going to keep the same digit, and after that we are going to reverse. So 0 will become 1 and 1 will become 0. So this is the 2's complement of 101. 1's complement of 101 is opposite of 0101. So 0, 1, 0, opposite of this one. So hope you understood how to find out the 1's and 2's complement of a given binary number. Now we are going to perform subtraction by using 1's and 2's complement. And it is also very easy. We will learn subtraction by performing addition only. Subtraction by adding the numbers, not by subtracting. Subtraction using, this is the first case. So actually what is this complement doing? This 1's and 2's complement are representing negative numbers. For example, this one. Suppose if this is a positive number, then this is a negative number. This is also a negative number. So 1's complement of this is this one. This is a negative number of this. Suppose if this is 3, this is minus 3, isn't it? So this is the minus of this one. My negative value of this number. So there are two ways, both are correct. So in this case also, this is negative of this one, this also negative of this one, same number only, but by using different methods. So you will understand once we complete the subtraction part. Now question number 1, we will do only one. Okay, so let's take one number, 110 minus 11. So we are taking only binary numbers because 1's and 2's complements are applied in binary numbers only. There are two numbers, 110 and 11. So we are going to subtract 11 from 110. So the first rule says, I have given you the rules in the PDF file only. You go through that PDF file, okay, you will find. Okay, the first rule says we have to balance the number of bits. Okay, as you can see in the first number, there are 3 bits, and in the second number there are only 2 bits. So we have to balance the number of bits in both the numbers. So how to balance? We have to add extra zeros on the left side, not on the right side. Because if there is 5, then if we add extra zeros on the right side, then it will become 50, 500. The value will keep on changing. But if we add zeros on the left side, the value remains the same. So we are not allowed to add zeros on the right side. Okay, so we have to add zeros on the left side. Understood? Now, in order to balance the number of bits, we are going to add extra zeros. So after adding the extra zeros, 110 minus, it will become 011. Isn't it? Now, this is the first rule. Now, the second rule says you have to find the since this is the 1's complement. So we have to find the 1's complement of the negative number. So after that, this will be defined. After we find the negative of this, we don't have to write minus sign. So let's find the ones complement of the negative number. Negative number is 0, 1, 1. So 0, 1, 1, ones complement of 0, 1, 1 is just the opposite, okay, isn't it? 0 means 1, 1 means 0, 0. So this will represent the negative of this one. Means this will represent this one. This one. Now we have this one already as positive number, and this is represented like this. Now we can add these two. Now addition can be done between the two numbers, that is the positive number and the result that we got after finding the complement. Now 1, 0, 0. Now you can add. So this is the carry, right? This is the extra digit after adding the 2-digit numbers. Now here also this one is the extra one. Now if there is carry, then remove this, okay, then bring this one here and add to the final result. Remove the carry and add 1 to the remaining part. Now 0 plus 1 will become 1, this is 1, and this will become 0. So this is the final answer. What if there is no carry? If there is no carry, then simply write the answer as it is, okay, and then place a negative sign at the front. And if there is no carry, then you write the answer and then place the negative sign at the front. This rule is given in your PDF file. You can check that. Now this is the subtraction. This is the answer. 1, 0, 1, 1 is the answer for this one. So 1, 1, 0 minus 1, 1 will become 0, 1, 1. Right? Now we will perform this same subtraction by using 2's complement. So same question, but by using 2's complement. Now the question is like this: 1, 1, 0 minus 1, 1. Now the same thing only. First rule says that we have to balance the number of bits. Okay. So 1, 1, 0 will become, 1, 1 will become 0, 1, 1. We have balanced. There are 3 digits. Here also 3 digits. Now we will find the 2's complement because we are performing 2's complement subtraction. That's why in this case we did 1's complement, but here we will choose 2's complement. This rule is also given in the PDF file. Okay. 2's complement of the negative number. So 0, 1, 1 will become. So how to find the 2's complement? You remember, right? So for 1's complement we just reverse the bits only. So 0 became 1, 1 became 0. But in this case we will try to find the first one from the right side. So from the right side the first number is only 1. So we will copy the same here only. We will write as it is. Okay. Then after that the remaining digit will be reversed. Okay. Now this second one will become 0 and this one will become 1. Yes. So this is the 2's complement of 0, 1, 1. So this was the 1's complement. 1, 0, 0 was the 1's complement. 1, 0, 1 is the 2's complement of the negative number. Now this will be represented as this one. Minus 0, 1, 1 will be represented at this one. Now we have two numbers, 1, 0, 1 and 1, 1, 0. Now we can add these two numbers. 1, 1, 0 plus 1, 0, 1. So by adding only we are performing subtraction. 0 plus 1 is 1. 1 plus 0 is 0. And 1 plus 1 is 0 carry 1. So this is the answer. Here also there is carry. Okay. Now in 2's complement subtraction rules, if you observe rule number 4, it says that if there is carry in the result, so obviously there is carry, right? So in the 1's complement we used to remove this carry and add 1 to the remaining part, isn't it? But in case of 2's complement we just have to remove this carry part, okay, and write the remaining as the final answer. Oh, sorry. 0 plus 1 is 1. 1 plus 0 is also 1. Sorry. Now 1 plus 0 is 0, carry 1. The remaining part is this one. So we just need to remove the carry part. So this is the answer. As you can see, compare the result. This is 0, 1, 1 is the final answer. Here also 0, 1, 1 is the final answer. So answers are same whether we follow 1's complement or 2's complement. But 2's complement is better than 1's complement. Why? I tell you. Okay. For example, if we are performing subtraction between the same numbers, okay. Let's say for example 1, 1 minus 1, 1. Okay. Obviously the answer will become 0, isn't it? But let's try to solve this by using 2's complement. Now 2's complement of although this digits are balanced. Now 2's complement of 1, 1 is how much? From right side, let's check that. 1, the first one will be copied as it is, okay, and then second bit will be reversed, okay, so 1 will become 0. So this is the 2's complement of the negative number. Now we can add these two, this one and this one. Now add 1, 1 plus 0, 1. Now 1 plus 1 will become 0. 1 plus 1 will become, 1 plus 1 will become 0, carry 1, and this one will become 0, carry 1, and this carry will come here. And if there is carry in the second complement, then this carry will be discarded, avoided, or you can remove this carry and write the remaining as the final answer. So 0, 0 means 0 as the final answer. The answer is correct in case of 2's complement. But what if we perform the same difference, okay, subtraction, by using 1's complement? So let's perform this also. Let's okay, first the numbers are balanced, okay, number of digits are balanced. Now in the second case we will find the 1's complement, in this case of 0, 1, 1, 1 only. So it will become 0 and 0 because 1's complement just the opposite of the digits, isn't it? So 1 will become 0, this one will also become 0. Now we will add these two. So this one and this one. So these two will be added. So 0, 0. Now let's see. This is 1 and this will also 1. Now if there is no carry, you can check the rules. If there is no carry, then you have to find out the 1's complement of the result. If there is no carry, isn't it? There are two digits, answer is also in 2 digits. Okay. Now if there is no carry in the result, then we have to find out the 1's complement of the result and place a negative sign at the front. So let's try to find out the 1's complement of this result. So 1's complement of this is just the opposite, isn't it? 0, 0. And place a negative sign at the front. So this is the rule, negative sign at the front, okay. So the answer will come as minus 0. This is the answer. This is the answer. Now as you can see, in the first case, means in the 2's complement, the answer is 0, and in the second case the answer is minus 0. Minus 0 is wrong, isn't it? Because there is no plus minus for 0, isn't it? It is neutral number. It is not positive. It is neither positive nor negative, isn't it? So minus 0 is wrong. So when we subtract the number from itself, okay, then we will get negative value in case of 1's complement. So in case of 2's complement, it is okay. So we follow 2's complement subtraction. Computer follows 2's complement subtraction. So while designing the circuits, okay, it follows 2's complement operation. So this is the case. So I will give you the questions also. You try to solve. You try to follow the rules. First you go through the rules. If in the case of 2's complement, if there is no carry, then you have to follow one rule. So I didn't teach you everything. You can follow the rule.